from Utrecht University, the Netherlands. The Honorable Director of Simeo Regional Center for Kitab in Mathematics, Dr. Sumardiono. The Honorable Deputy Director for Administration, Dr. Susetyo Widyasmoro. The Honorable Deputy Director for Program, Dr. Farida Nurhasanah. Esteemed Committee of SIKIM and distinguished offline participants in conference room and participants who stream online on SIKIM YouTube channel. Good morning and Assalamualaikum warahmatullahi wabarakatuh. It is our pleasure to welcome everyone to the opening ceremony of the seminar on supporting the development of numeracy for primary school teachers. Today, October 20, 2022. This event is organized by the Simeo Regional Center for Kitab in Mathematics, or often shortened to SIKIM. As one of the regional center under the Ministry of Education, Culture, Research and Technology of the Republic of Indonesia, SIKIM has conducted several courses, training, workshops, symposium, seminars, and research to address the latest issue in mathematics education. This event is conducted in offline mode and streamed live on SIKIM YouTube channel. Ladies and gentlemen, this event aims to facilitate primary school teachers in developing innovative learning by introducing joyful numeracy activities for primary school students. Ladies and gentlemen, to start the opening ceremony is Indonesia Raya National Anthem and Simeo Colors. Ladies and gentlemen, please rise.
Indonesia Raya.
Ladies and gentlemen, we are presenting you the Simeo song, Building the Future. Please enjoy the video.
It's time to open our eyes to a bright and promising future. We'll rise to the call of the times and create a stronger tomorrow. Let's start to make a difference, teaching everyone to learn through science, health and technology. We will share our expertise. By promoting knowledge and policies, we can build a better world. Let us take a step for our visions alone, bringing future quest for the people to grow in a life filled with happiness and green. Here in Ceremonial, building the future is our legacy. We'll achieve our goals through partnership, creating opportunities. By working hand in hand, we can accomplish all our dreams. For a better quality of life is now within our reach. Let us take a step for our visions alone, bringing future quest for the people to grow in a life filled with happiness and green. Here at Ceremonial, building the future is our legacy. Let us take a step for our visions to home, making future quest for the people to grow in a life filled with happiness and green. Here at Ceremonial, building the future is our legacy. Building the future is our legacy. At
Ladies and gentlemen, to begin the program, I would like to invite the seminar supervisor to deliver the committee report. Mr. Suhananto, the floor is yours.
The Honorable Associate Professor Dr. Maarten Dolk from Utrecht University, the Netherlands. Honorable Dr. Sumadiono, Director of Semi-Academic Mathematics. Honorable Dr. Farida Nur Hasana, Deputy Director for Program Semi-Academic Mathematics. Honorable Dr. Susutyo Widasmoro, Deputy Director for Administration Semi-Academic Mathematics, esteemed participants, and my beloved colleagues at SIKIM. Very well, good morning. Assalamualaikum warahmatullahi wabarakatuh. It is a great pleasure to welcome you all to Ceremonial Regional Center for Keynote in Mathematics, today, 20 October 2022. I speak for the entire committee in saying we are so happy you have passed the selection process to join this seminar. Congratulations. I'm sure so many mathematics teachers out there would have wished to be part of this seminar, but due to many reasons, they haven't yet got the chance. Our center very fortunate to meet you. And on the other hand, I'm sure that that this program offers a window of opportunity for you as individuals to improve your quality as teachers. I'd like to inform you that among us here, we have 20 participants coming from Yogyakarta. They are primary school teachers that will learn and share experiences about numeracy. Ladies and gentlemen, numeracy along with literacy have been a focus in the Ministry of Education, Culture, Research and Technology of the Republic of Indonesia. Indonesian student performance in numeracy have never been satisfactory. During the COVID-19 pandemic, it has been predicted to get worsened if serious actions are not carried out, especially in primary school level. Therefore, primary school teachers need to continue to develop innovative work related to numeracy learning, so that it supports students applying mathematics in daily life and contributing to a better society. One of the efforts in supporting teachers to develop student numeracy skills, SIKIM conducted a seminar on supporting the development of numeracy and invited an expert from Utrecht University, Associate Professor Dr. Maarten Dolk, so that teachers can learn and get inspired to adapt in the classroom and learn enjoyable numeracy activities. This seminar aims to introduce numeracy, number sense, and a variety of numeracy activities for primary school students. Ladies and gentlemen, to give our best service, the committee has managed anything related to the seminar, so please do not hesitate to contact us when you find difficulties. I hope you enjoy the new circumstances in our center, and we will also highly expect good cooperation from you in order to make the seminar run well. Next, may I invite the Director of Semi-Kitab in Mathematics, Dr. Sumardiono, to officially open the seminar when the time comes. I sincerely hope you will enjoy today's discussion and networking. Thank you, and wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Hanto, for your warm welcome to everyone joining us today. Ladies and gentlemen, I would like to welcome the Director of Simeo Regional Center for Kitab in Mathematics to deliver the remark and officially open the seminar. Dr. Sumardiono, the time is yours.
Okay, the Honorable, the Associate Professor Dr. Maarten Dolk from the Utrecht University, Netherlands, the Honorable Deputy Director of Administration Dr. Setiwida Smoro, the Honorable Dr. Farida Nur Hasana as Deputy Director for Programs, esteemed participants, and also the committee of SIKIMS. A very good morning. Assalamualaikum warahmatullahi wabarakatuh. It's my honor to welcome you all to this a day seminar on supporting the development of numeracy for primary school teachers. In this morning, we're happy to have Associate Professor Dr. Maarten Dolk, for the last attending to the SIKIMS, I think in March 2020, that's in the situation of the early pandemic, so that's maybe scary us about the course, but now we have passed, the emergency, I think, about the pandemic. So we hope that the pandemic can be finished, and we hope that the situation can be normal, and we can do every program normally. And I think that from the pandemic we learn much about how we use the technology also. And for now, unfortunately, we don't have resources to invite more participants to this meeting, so we invite only the participants from Yogyakarta. But as mentioned by the committee. Others who have interest with this seminar could join via YouTube, YouTube streaming. Ladies and gentlemen, the participants and also the Maarten Dolk. We learn much, from the Netherlands. I think since I become a student of postdoctoral, I learned much about the realistic mathematics education also. So we are teachers and educators from Indonesia, learn much from the development, about the many approach and new methods on mathematics teaching and learning. Especially now, even for the Ministry of Education, Culture, Research and Technology of Indonesia, we have the big policy about this paradigm shift, about how we provide the material, especially in mathematics, in the sense of beneficial for our daily activity. So the themes of numeracy is very important now. Not only this matching with the development of the new era, in mathematics education, because of also in Indonesia they meet with our policy about the Merdeka Belajar, or transforming learning, if I'm not mistaken. So again, I would thanks for this opportunity, to Dr. Maarten Dolk, and welcome to you all, the teachers of primary schools in Yogyakarta. I hope you can enjoy this seminar and participate actively and have the fruitful seminar. Without further ado, I declare the seminar on supporting the development numeracy for primary school teachers open. Thank you very much for your attention. Stay safe. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Bapak, for the motivation, remark, and officially open the seminar. Ladies and gentlemen, the next agenda is souvenir presentation from Sikkim to Associate Professor Dr. Maarten Dolk. May we invite the Director of Sikkim, Dr. Sumardiono, and Associate Professor Dr. Maarten Dolk to come forward. Thank you very much. Ladies and gentlemen, the next agenda is photo session for the offline participants, Board of Director of Sikkim and College. Please come forward. Well, thank you very much, everyone. Please give a round big applause to all of us. Well, ladies and gentlemen, on behalf of the organizing committee, I would like to thank you for everyone for joining the opening ceremony. For Board of Director of Sikkim, we are very happy if you could follow the seminar, but please do not hesitate if you have any other agenda. I will close this opening ceremony. Thank you very much for your participation, and wassalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, the next agenda is 5-minute refreshment. Please enjoy the refreshment, and you might bring the snack inside conference room. Thank you. Ladies and gentlemen, welcome back to the room, and we will start the session with Associate Professor Dr. Maarten Dolk. The session will be chaired by Mr. Wahid Yunianto, the Coordinator of Training Specialist of Sikkim. Please welcome Mr. Wahid Yunianto. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Very good morning, superheroes, our primary school teachers from Yogyakarta. I would like to welcome you again to this seminar on supporting the development of numeracy. Do you think numeracy is important? Yes, that's why you are here. Okay, I will be the moderator for this seminar. My name is Wahid Yunianto. I'm working here as a training specialist, and I will be helping you in interpreting Maarten talk if you need Bahasa Indonesia support. So I would like to shortly introduce you our keynote speaker, Associate Professor Dr. Maarten Dolk from Utrecht University. He was my course coordinator at that time when I studied at Utrecht. I was afraid of him at that time. He selected at that time. So he has done many work in the field of mathematics education, and one of the publication is about books. You can read the book. It is Young Mathematician at Work. I really like it. So we have number set, addition, subtractions, especially for primary school levels. It is interesting books. And he has collaborated with many experts in the US, in around the world. So without further ado, let's just step forward to his stations. Professor Maarten Dolk, the floor is yours.
Thank you. I will speak English. Saya tidak bisa berbahasa Indonesia. That's the only sentence I can say, and I can say it very fast. And when I say it in a taxi, the driver will talk to me in Bahasa, and I repeat it. Saya tidak bisa berbahasa Indonesia. And I have to do that 3 times, and then the taxi driver understands and is silent the rest of the trip. I have to tell you the Netherlands. We're known for tulips. But we talk about numeracy. Now, for 1 minute, write down on your notepad, what is numeracy? When do you think somebody is numerate? If we ask you, are you numerate? How would you show that? So write down what you think is numeracy. The Ministry of Education in Indonesia talks a lot about numeracy. So, if that is important in our classes, we at least need to know what it is. But often people in education use a lot of terminology where we as users hardly ever talk about, or we don't know what it is. So, who would like to share what you wrote down. Who would like to share what you think numeracy is? Yes?
Misconception, because this is the first time I get here because of my friends. So thank you for her. I think numeracy is an ability to how to read some numbers and count it, or maybe solve the problem with several numbers, and it did in our daily activities. It relates with our daily activities is numeracy. So this is, I think it's very important, especially for my student in primary school. Thank you.
Thank you. Who likes to add something?
Well, actually, it's almost the same with what have already been explained by the previous speaker. In my opinion, numeracy is learning on logical thinking to solve problems that is related to numbers calculation or number operation. Yes, that's my opinion.
Yeah, maybe in simple sentence, numeracy, I think it calculate to any materials of number.
Materials of number. Can you say a little more what you mean with materials of number?
Maybe something that like the water or the box or anything. It's about in what is in our environment, and then the materials is convert to the numbers.
Thank you. I don't know about Indonesian newspapers, but American or Dutch newspapers during COVID would have all kinds of graphs about the spread and the growth or the decline, about the risks. And those graphs usually had many layers of information at the same time in one image. You needed a lot of mathematics to be able to understand the information, to be able to read the information in that graph. Where, and I have not checked it, but I'm almost certain 100 years ago, when we had the Spanish flu, probably most articles in newspapers were telling about the Spanish flu in words. We now are a much more mathematical society. We do it in graphs. The Western world is afraid of recession. So they publish in newspapers articles about, will there be a recession? Earlier, there would be the idea of one or two important economics. Oh yes, there will be a recession. Oh no, there will not be a recession. Now, because they don't want to give fake news, now they ask 100 experts and they give a graph where they say 15% of the experts think that next month the recession will begin, 20% thinks it will start in 3 months, 45% thinks it starts in a year. So instead of a yes or no answer, you get a mathematical answer. You have to be able to read that graph to understand whether there will be a recession or not. Very close to home, when I'm in Indonesia, I use Tree. And so I have money on Tree, and then I have to buy some internet. And all of a sudden, I get 25 different options with 25 different kinds of contracts. And so I have to wonder which of those contracts is best for me. Some contracts I have to say stop after a month, otherwise they will subtract money, and that is not useful for me. But the ratio between how much I pay and how much internet I get is important. You need quite a lot of mathematics to be able to understand what those offers are. In newspapers, they often talk about numbers. In Indonesia, we have 1,000 COVID patients in a hospital. In Malaysia, they have 700 COVID patients in a hospital. Oh, Indonesia is worse. Now, wait a minute. The 1,000 and the 700 are absolute numbers. But it is 1,000 out of 240 million people. How many people live in Malaysia? I don't know, to be honest. How many people in Malaysia? Hey, to be able to understand 700 and 1,000, not only you need to understand the mathematics, you also need some data in the background. You need to know how many people do we talk about. 700 out of 20 million? Do we talk about 700? Oh, you need to understand the difference between absolute and relative data. To me, that kind of being able to understand society is numeracy. And so I never talk, when I talk about numeracy, I'm not talking about problems in school. Because those problems are to make our students numerate. But I talk about what is it that a 25 or a 45-year-old person in Indonesia needs to understand what's going on. What is it what you need to understand what party to vote for? What is it that you need to understand if or not to buy a house in a certain region? All that kind of information. That to me is being numerate. It is important because if we are not numerate, it's very hard to understand the world. It's very hard to understand what governments are doing. It's very hard to make sure that you get the best out of your life. And it's getting more important over the years. So our students will probably need much more numeracy than we needed. That is difficult. When I was young, down the block, there was a house, and they said it contained one computer. Well, at that time, computers really needed to be debugged. That literally was getting bugs that crawled over the computer out of the computer. And my school never talked about computers. But now, a computer and everything is so much important part of my life. That change between what happens when you're a kid to what will happen in the future, that is what we have to deal with. We have to prepare children who will be grown-ups in 2050, 2070. And we cannot predict how the society will be, but we can maybe create a society for that. That is what we are talking about, numeracy. But then again, we work with primary school children, so how do we create it? Now, I want to start with a few issues where I say numeracy is happening here, but what is happening here? This was a problem in a Dutch textbook, and I was in a class in the Netherlands, 11-year-old children, and they work with a computerized system. I personally don't really like that. And this was one of the problems. And the teacher was talking with them. The problem, how many dollars for 100 euros? But of course, there is hidden a lot more information. Because hidden is, how do you even read this table? It is in the Dutch language, but you might maybe recognize the abbreviations. American dollars, British pounds, Moroccan dirham, the Czech kroner, the Turkish lira, the Swiss franc, currencies that are important in Europe. And then the daily exchange rate, and then it says 1 euro is 1.17 USD, and 1 USD is 0.85 euro. Well, I wish it was still like that. It is not. Euro really declined, and the dollar grew up. You have to be able to understand what the table is, what the data is. You even have to understand that there should be a relation between the 1.17 and the 0.85. I'm a freak, so I compared those two, and I noticed that there was a mistake at the table. You could make money out of it. And in reality, some Wall Street people are really looking at all those tables to see if there is a ½ cent difference between exchange rates for different banks, and they make money that way. A mistake in that earns one of the people in Wall Street money. So it's something that happens. Often the tables are more complex in newspapers because there is a buying and a selling price. What is also different. You buy for a different price than you sell. But what is buying? What is selling? What is the transaction? There's a lot to understand here. But the mathematical assignment was much simpler. The mathematical assignment is how many dollars for 100 euros? And somehow the children know, okay, that is 100 times 1.17. And so the child is, okay, 0.1700. And the explanation is when you multiply by 10, you put a 0 behind it. When you multiply by 100, you put 2 zeros behind it. But if you don't understand place value, you don't know what you're doing. And here is a moment where you see that understanding of place value is critical to understand what it means. Multiplying by 100 is not putting a 0 behind it. No, 18 multiplied by 100 means I have 18 hundreds. 18 notes of 100, 18 groups of 100. That is different from just putting zeros behind it. In the same class, a child had to calculate 300 times 50. My expectation of numerate people is that they immediately say 3 times 5 is 15. And hey, 110, oh, it's 15,000. My expectation is that if a student is numerate, they can do that with their head. They can calculate it by really looking at the numbers. The child did this. It's a correct answer. But how meaningless is it? How meaningless is it to multiply 0 with 0, and 0 with 0, and 0 with 3? This kid is a computer that has a program that's not very smart, but is definitely not thinking. And we are no computers. Reality is that we should be the ones who give the task to the computer. We should be the ones who tells the computer, you have to do this. Finding the right questions is often the most difficult part. When I look at my life, when I got calculations that take a lot of time, I use a calculator. But I know what to do and how to do it. This was only the calculator. To me, that is not numerate. To me, performing a procedure without thinking is not numerate. So you have to understand place value, it comes back. You have to understand analogy. You have to understand that 3 times 5. Then I also know something like 3 times 50, or I know 30 times 5. It's 10 times more. The 3 times 5 is helpful to calculate so many other things. And of course, you need to know your basic facts. If you don't know 3 times 5, 14, isn't it? I was in a classroom yesterday, last 3 days, grade 3. Half of the class was still finger counting. I think that should be not acceptable. You should, by then, start to know the basic facts. But I also know that when I look in Dutch classrooms, that a lot of children still don't know the basic facts at that age. So it's not an Indonesian problem per se, but it's an educational problem. How do we make sure that the basic facts are there? And how do we do that? That's part of how do we develop numeracy. Now, I know 3 times 5, so I know 3 times 50, because it is 3 times 5 tenths. Yeah, at a high level, you could say that it's the associative property. A times B times C, and I can put those brackets in different ways. That is the algebra that you get in secondary school. Of course, we don't talk about it in that way. We talk about it in a way that is understandable for children. And 15 tenths is 150, that's place value. So I could also say, and that is what the children say, 3 times 5 is 15, I add 3 zeros. Half of the class will say that. And think that if you want to develop numeracy, that is an important thing to say to children. You add zeros, 15 plus 0 is 15. What are you talking about? And you have to start to talk about how do we develop the notion that 10 times is important. In the Netherlands, it's easy because we have banknotes of 10 euros. So I can talk about 3 10-euro banknotes. It's a nice context. Your Indonesian currency is not very helpful. Unless you talk, of course, about 10 ribu. I have 3 groups of 10 ribu. Maybe that helps. But in Indonesia, we might have to find different contexts to develop that notion of place value. In the Netherlands, money is used a lot. So you could think about an area model. 3 times 5. I talk with the children why this is 3 times 5. If they don't yet have seen it, area model, a model is important to me. An area model is important if I start to talk about multiplication. It's one of the ways to think about multiplication. So if this is 3 times 5 is 15, you can count them if you want to. Then 3 times 5 times 10, 3 times 50, well, 10 of those. 4, 5, 6, 7, 8, 9, 10. And all of a sudden I can see 50 horizontally, 3 times, 50, 50, 50. I can see 15 10 times. I can look at it in many different ways. I can talk about it in many different ways. So developing the ideas of place value, developing the ideas of multiplication by tens, etc., you need to start to think about models and contexts that will help students to do that. instead of giving the rule, remember you do that. Remember it? I will ask you tomorrow. Remember it? You didn't remember it? Just giving rules is not helpful. It creates problems. Problems like this. From a school here in Indonesia, we were working with some context. We were asked to talk about division. Given some work with students on forehand, I had a doubt whether we were ready for division. So we created a context that could be solved in many different ways. This was the second day. And the context here was that, well, the context of the first day was that 250 people would come to my birthday party. I had invited a family, and I had invited that family, and they all sent back notes like, oh yes, we come, and grandma is coming, and my cousin is coming, and 250. It's an important birthday for me, so I had 250 people coming over. And in the story, we said, I love donuts. So I wanted to give everyone a donut. And so I went to the donut store and I said, I need 250 donuts for next Saturday. Oh, sir, sorry, sir. We don't sell just donuts. We sell a box. And the box contains we said the box contains donuts. Well, this is the box. I looked at it. Oh yes, there are those holes in the donuts. The most delicious part of the donut. So, this was the first day problem. So there are 12 donuts in a box. We made the drawing a little bit complex. Because the idea was that children might want to draw all those boxes. And they might want to count. They can solve the problem at the lowest level. They can solve it by counting. I draw a box, I draw the 12 donuts, all the holes in it, count, continue counting, continue. They can solve it at that level. It would take time. And I hope they hate me for that. Because if they are lazy and they think it's way too much work, that is a reason to look at a smarter, a better, a nicer, a quicker solution. So if you get lazy with counting and you realize I make mistakes and I have to start over, 12, 23, 12, 24. If I have to do that 3 times, then maybe you are forced by yourself to move 12, 24, 36. There is a suggestion, you can count. There is also a suggestion, you can use the 12s. And the constraint is a larger number. If I had said that 36 people came to my party, the counters would be happy. 250 will make them hate me. And that was the implication that we had with this content. We wanted them to move there. Reality was that when the teacher introduced it, the teacher forgot to make the drawing. And most children started by counting, and I've seen girls just tallying. That didn't help. So we said the next day, those 250 people are coming. And of course, I need to have a place where I can have them. So I went to a local restaurant that I know it's good food. And I said, I will come here next Saturday, 250 people, can you have us? Oh, the owner said, oh, no problem. Have big tables. And you can have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 people at a table. And I have a lot of those tables, 14 people at the table. You just tell me how many tables you want. I will put them down. Precisely the same problem for us. For the children, it's a different problem. And that is where we are. So at that moment, because the kids had already seen the algorithm for division by 8 and division by 5 and whatever. They have never seen it for division by 14. But there we are. The children try to use a procedure that they didn't really understand. And some of the mistakes that children made are mysterious to me. I really don't know why, what they have been thinking. But 250, subtract 14. I understand that. That is, find the largest group of 14 that fits in 11. And then subtract 10. Or subtract 11. I don't know why and where that 11 is coming from. But so what happened is that the teacher, and we all do that, the teacher had introduced a procedure that the children probably totally not understood. And now the children are trying to make sense of the procedure they don't know. And they use half of the rules, or they use some of the rules. There is no thinking. And to be numerate, you have to start thinking about what you are doing. You have to start thinking about the numbers. You have to be able to start thinking about the mathematics. So I need a lot of tools to be able to think. And if I don't have the tools to think, I cannot be able to use new procedures or create new procedures, invent procedures. And that is what was asked here. The teacher had never told them how to divide by 14. Our attempt was different. What we wanted was that the children would start to think about repeated addition. And some of them really made long rows, mathematically incorrect. This was difficult already. 8 and 4 is 12, and what to do now? And these kind of long rows were there. It's interesting. It's a division problem, but they see the multiplication. Well, in reality, they didn't see the multiplication, they saw the addition. Hey, the relation between subtraction, addition, multiplication, division, there are relations between those. And so, to be numerate, that kind of relations, the big idea of how those operations are related, is extremely important. There was one group, happily, who, in a conversation with one of the teachers who was present, started to do 3 tables and said, do I do that right? That's 42. And then they drew another group of 3 tables and they said, that's 42. They started to use a group of groups. The 14 is a group of 1 table. But to be able to think about 3 groups and use that as a new unit helps you enormously, because now you don't have to add all those 14s anymore, you only have to add the 42s. And so, in our next problem, we wanted to use that idea of those 42s. But before I talk about that, a little more of the attempts, but also this one. Any idea what's happening here?
There is something what strange with 28 plus 14, because 20 plus 8 is 8 plus 4. He or she wrote 12, and then 2 plus 1, he or she wrote 3. So 28 plus 14 becomes 312.
I'm sure that you have seen this mistake in your class from time to time. We all have. The fact that children make the mistake is not a problem. The fact that we created the situation where the mistake is made is the problem. What did we do wrong that happened? And I'm sure we all saw it happening. So in this situation, we have children who don't really know the addition. We have children who try to use a division algorithm in situations where they don't understand it. And then we come with those large numbers. So it's a class where a lot of mistakes were made. But in general, students moved from counting to adding on 12s or 14s, depending on the problem. And now one group is already grouping. And so we talked about it and we said, you know, the next problem, we should create a context where we can group 10 tables. Because if they now use 10, then that is getting close to all the algorithms. And so our next problem that we designed was, again, large numbers. I'm not afraid of large numbers for children. So 928 people, a school, all the students, all the children, a few parents, are going to a fair. And the teachers start telling the story, and the children live between reality and school context. So they are not really sure, are we really going to a fair? And you're going to buy cakes for us? Do we really get cakes? They were yelling. And I wanted to buy cakes, the teacher says, for all those 928 people. I went to the bakery, and they sell it in boxes of 18. Teacher draws cups, draws all the cakes, all 18. A second box, only the number 18. And then the teacher said, so I thought I was done. And then the baker said to me, because it's for your school, for every 10 crates that you buy, you get a big leather ball. Well, the children were interested in that leather ball. That would be great too. And our attempt was that children would start using 10 groups of 18, and then adding on the 180s. Do you hear how we slowly start to build multiplication algorithm? Because they don't see it as an division, they see it as repeated addition, so they still use multiplication. Now, the problem is that doing that, we run into all these, oops, why am I going too far? We run into all these problems. And so to develop numeracy, we have to avoid these problems. We have to do two things. We have to slowly start to build numeracy for students. We have to create good context that would allow for that. And we have to be sure that children don't see themselves as calculators, but they see themselves as thinkers. There was enough listening so far, so I want you to work. You have done nothing so far. I've done all the work. I want to see how numerate you are. And I slowly showed already a slide that was not smart. So, could you solve these problems for me? Can I stop you for 1 minute? Because when I look around, there is an interesting difference in the group. Some of you are thinking, and some of you are calculators. And I don't care who is the calculator and who is the thinker, but I want you to approach the problems as a thinker. So, some of you do this. If you do that, you're the calculator. You used the algorithm that you were taught when you were 10, and you do it perfectly because you're a teacher. I hope you do it perfectly. 3 and 8, blah, 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 blah. I'm not interested in that. That doesn't make you numerate. It makes you a good calculator. And we have machines for that now. So it's a waste of your capacity. If you ask children to do this, they will do this. It's the explanation that you gave earlier. 8 is 11. 3 and 9 is 12. 3 and 9 is 12. 3 and 4 is 7. Constance Camille, a researcher in the United States, researched the kind of errors children make when they are calculators versus thinkers. The calculators made huge errors. 3,000 and 4,000 can never be 7 million. Is it million? Yeah. The place value doesn't add up. But if you're a calculator, you don't look at that. You make those errors. If you're a thinker, you still make mistakes, but your mistakes are very close. So the error is not as large. So this is wrong too. So what do thinkers do? Well, there are different ways to look at it, but thinkers can, for instance, do this. They can move 2 from the 3,333 to the 4,998. Those numbers are so nice. I say 5,000. I don't think 4,998. Are you stupid? You're a shopkeeper. You sell something for me at that price, 60,999,000. Just tell me it is 70 million. So adding 5,000 is easy. You should be able to do that with your head. And I just have to compensate the 2. And I can do that in different ways. That would be a way of a thinker. I see some people do, oh, so it is 3,000 and 4,000, it is 300 and 900, it is 30 and 90, it is 3 and 8. It's kind of in between the calculator and the thinker. Now, I know you're teachers and you can solve all these problems as calculators. I don't want to be convinced by that, I know that. So I ask you, solve these problems as thinkers. You don't have to prove you can calculate it. I trust you. Think. Find interesting ways that a thinker can solve these problems. And of course you have neighbors, so talk to your neighbor. You don't have to do it by yourself. Yes, I hear myself. The number line allows you to represent addition, subtraction, movement. Of course, you don't just say to the students, use the number line. No, you have to introduce a series of contexts to build their understanding of number line. But if you have an understanding of number line, and I say, hey, 3002 and 2998, I can subtract that by taking it away. I can take it away. That would be a hell of a lot of work. But subtraction has two forms. It is taking away, but it is also looking at the distance between the two numbers. And when I'm capable of seeing that subtraction has two forms, and I understand that this one is much easier than that one, then all of a sudden, it is quite easy. And so I make a jump of 2 to 3000, and I make a jump of 2 to 3002. The model number line helps to understand what I'm really doing. And at this level, children can do that. Now, some of you wrote this. Hey, now I make a relationship to algebraic thinking. Of course, it's not algebra. Most children will start to understand it like that. But if this happens in your class, you're preparing for something that the children here understand, because they understand that. You're preparing for algebraic thinking. Some people call that early algebra. And if you really look at thinkers in your class, you will see that there is a lot of early algebra going on. And that is the power of allowing your students to think. You're not doing something just for this year, and they are not just answering the question and coming up with a solution. No, their thinking is much more powerful. And of course, if that would happen in my class, I would probably at one moment ask, will that always be true? It's a very hard question. It's a question about algebra. It's beautiful if they do that, and if they start thinking about it. But that is the main representation that asks for an understanding of the number line. So building numeracy in my class asks for building a model of the number line. I need to find contexts and situations that will allow students to start thinking about the number line. I think I saw this everywhere. Yeah, 999, that's a stupid multiplication. I go to 1000. Then, of course, I have to do that subtraction. And I do that with my head, not in my head. But I use paper where needed. So I say 120,000, 100 less, 119,900, 20 less, 900 minus 20, 880. I know that. Oh yeah, and I add that 19,000. So I might have that in between answer on my paper, just to help me. But I don't do it as an algorithm underneath each other. Way too much work. I could do that, of course, on the number line. And I could represent my jump of 100 and my jump of 20 on the number line. Again, how powerful is that number line? But what I don't do, 9 times 0 is 0, 9 times 2 is 18, 9 times 1 is 9. Stupid work. I don't do that. If I can see division and fractions as related, and I can think of 400 divided by 16 as the fraction 400 over 16, and I know something about equivalent fractions, then it is the fraction 200 divided by 8. It's the fraction 100 divided by 4. And 100 divided by 4 at this age is an insulting problem. Of course I know that. So, once again, to be numerate, I need to know a lot about mathematics. It's not something I can drill my children into. Numeracy means I need to know the big idea that fractions and division are related. I need to understand how equivalent fractions work. And so once again, you are only numerate if you really develop all the big ideas of mathematics. I want to know the distance between 257 and 139. But that is the same distance as the distance between 140 and 258. I added 1 to both sides. It's the same distance. It's the same answer. Now, 258 minus 140 is already a lot easier. But if I want, it is the same as I add 60. So I add 60 here. It's the same distance as the distance between 200 and 318. I can make it by moving that distance over my number line. I can make the problem as easy or hard as I want to be. And I could have gone to 150 and 268. I could have made a hard subtraction easy, just moving it around. It's open. And that moving around is something that you have to help students invent. I've seen people who at a much later age get acquainted with this approach, and from then on did every subtraction this way. They would never use the column-wise subtraction. I'm a bit in between. I sometimes use this, I look at the numbers, and for some reason the numbers tells me, do this or do that. I see something in the numbers. There was a researcher in the United Kingdom who at one moment, she had a series of problems, not the easiest ones, and she asked them, can you estimate the answer? There were problems like 0.79 divided by 0.89. And she asked mathematicians, can you estimate it? And those mathematicians did it. They sometimes make mistakes, who doesn't? They estimated it, and they told her how she did it. And then 3 months later, I think it was 3 months, she asked those mathematicians again, can you estimate this? Almost all mathematicians used a different approach. So the same problem, but 3 months later, they looked at the numbers differently. So it is not that when you look at numbers, you always see the same. It depends on what you did the day before. It depends on what you did an hour before. So we cannot expect that if we give this problem to children, they always will do this procedure. If that happens, they are calculators. But if they look at numbers and they immediately say, oh, I see this, that makes it handy, then they are thinkers. And I think that to develop numeracy in your class, you have to create those thinkers. So to me, I will definitely talk about the answer, but when I have this problem and I talk with students about it, a very good chance that I will say, okay, we solved this problem. You know, the answer is 118. But how did you do it? Hey, how did you do it? My focus will not be on what is the answer. My focus is on how did you do it? Hey, is that the same way as he did it? Is there a difference? Hey, is your method related to his method? How does it work? Let's take a break. Baba Heat, how long is the break? 15 minutes. See you back in 15 minutes. And we start with questions. So if you have things that you like to talk about, if you have questions, and you want to say it in Bahasa, in the break, go to Papa Bahit. Don't give him a break. Make sure that he works. Enjoy coffee, tea, snacks.
Cukup atau kecepatan? Cukup. Ada pintu bertahan. Ya, jadi kapan saja jika ada yang ditanyakan stop dia. Jadi dosen-dosen Belanda biasanya kayak gitu. Kalau nggak tahu langsung di stop saya tanya. Gitu. Nggak harus menunggu sampai dia selesai, jangan. Nanti lupa. Pokoknya saat itu nggak tahu, saat itu pengen tanya langsung tanya saja. Misalnya tadi itu maksudnya number line-nya gimana, itu kekecilan, tolong bisa gedein dikit gak gitu kan, misalnya nggak paham maksud itu apa gitu, tanya aja. Iya. Ini tanya boleh ya. Ya, nanti kita dengarkan jawaban dari Maarten. Ya, baik. Karena udah kelas 6 ya, terlambat sih. Tapi nggak apa-apa. Ada lagi Bapak yang ingin ditanyakan? Menggambar donat? Oh, gimana caranya? Udah ada lapar. Oke, baik. Baik, nanti kita lihat jawaban dia. Ada lagi Bapak Ibu yang tadi mau disampaikan terus belum jadi? Ada nggak? Oke, siap-siap. Nanti saya sampaikan. Di mana dia? Ya, ada lagi Bapak? Baiklah Bapak Ibu, siap lanjut? Siap, saya kalau bilang numerasi Bapak Ibu yes, yes, yes gitu ya. Oke, siap? Numerasi, yes, yes, yes. Satu kali lagi, numerasi, yes, yes, yes. Terima kasih. Oke, let's continue our sessions Martin. And before that, I have around 4 questions for you. Okay. So there are 4 questions coming from 4 teachers. Okay, first, from teachers who teaches in grade 6, he asks you about the advice or suggestions when he teaches area of circle or circle because it appears in the assessment. And it needs, of course, calculations because you have the formula of the area and students make mistakes in doing the calculations. So how to resolve this kind of problems? They have to find the area, but they have to do calculations. If they are not taught the procedures, then they could not find the answer. And now they just saw your presentations that there are alternative ways or more thinkers ways to do that. So how would you suggest to fix this with their students? And another questions. Oh, do you want to answer this first?
No, go on.
Okay.
Time to think about it. It's not an easy question.
Okay, and then another question is, what kind of tips and tricks that you may offer to them for this? And then the third one, about how to teach thinker to students, not like drilling. This is no. I mean, what would be your suggestion about this, the tips and the tricks? And the interesting question is that when they saw you drawing the donuts and the box, you draw it pretty like similar to the real donuts, and he feel hungry. How could you draw in such way? So yeah, I think those are the questions, and more into questions.
I have 3 questions. You said 4 questions.
But because the assessment are similar, I mean, tips and tricks, and the last one is how to make students love mathematics.
Oh, okay.
Okay, the last one.
I'm never sure how to make sure that students love mathematics. So I'm not sure if I can answer the question, but what I notice is that in classes where students are just doing problems and doing 20 problems, it's boring, it's not really interesting. I see classes where they do that on the computer and they have to fill out answers and they click, and then when you click next page, the computer says if you did it right or wrong, and so a lot of children are just filling in things, click, oh, it is wrong, do it again. That will, I think, never lead to understanding, loving mathematics. I've seen students in classes where context are used, and the teacher introduces the story and tells about it. And very often there is a kid in class, and I've seen that a couple of times, that at one moment says, "Is it real?" And so the teacher was capable of telling a story that is a mathematical problem, where the students understand this is a school mathematical problem, but at the same time, the story is so realistic. So they realize what you can do. Realistic comes in an important way from realizing what you can do, not from real life. You can realize what you can do, but they see that story so good that they say, oh yes, this could have happened. So that box with donuts and a big birthday party, yeah, the teacher could have had that birthday party and could have gone to the donut shop to buy those donuts. But then again, this is school, so probably it is a school problem. And it is in between those two. And when the children now can use common sense, not procedures they don't understand, they can use common sense, they can talk with their neighbors about it, they are used to talk with their neighbors, then I often see that a lot of the children start enjoying doing it. Sometimes the children don't even understand they are doing mathematics. But it's nice, and they like doing it. So why not? I deeply believe that children are interested in thinking. Children play computer games. And researchers, now I don't remember his name, sorry, a researcher, literacy researcher in the United States, became father, had a young child started playing computer games, and he said to himself, oh, I can teach my child how to play that game. And so he started playing the games himself. And he discovered that there is so much learning going on in playing the game that he started to look differently at games. And then he started watching the rules of children. The rule, if you play games, is I want you to give me a hint, but don't tell me what to do. Because if you tell me what to do, you steal my computer file. But I'm stuck, so I need something. Now, I try something, and in most computer games you die. I don't know why, but it is very violent. You die, and you try it over. You are allowed to fail. That is the life of children. And so, if you look at computer games that way, you can look at education that way. And there are people who compare good education to a lot of the ideas behind computer games. Allow children to talk about ideas, but don't give them the rule. Make it an investigation where they really have to investigate what to do. Allow them to make mistakes and to say, okay, let's start over. Let's try it another time. Instead of saying, oh, you didn't understand it yet, you're a fool. And we teachers are very good at giving that message. And so I think developing fun in mathematics is allowing children to explore mathematics, to be mathematicians, to be allowed to make mistakes, to be allowed to try and take more time. We expect that children solve a mathematical problem in 3 minutes. What do I say? 2 minutes. Reality is that in a good problem, you take sometimes a day, sometimes a month, sometimes a year. Some mathematicians have been working on a problem for 5 years. And we think that they have to do it in 1 minute. That is not real life. So as long as we don't give mathematics as a real thing, but as a fake school subject, I don't think the children will enjoy it. Let's make it a real thing. That would be my take on it. And my experience is that I see a lot of children enjoying it. Now, the circle, I've never really thought about it. We don't really do that in that way in primary schools. But we have rules for the perimeter and for the area of a circle. But how do we make sense of that rule? Where's that rule coming from? I personally think that doing calculations is maybe too early. But thinking about the perimeter could be very interesting. Now, we have done investigations where we said the perimeter is 20. But what is the area? And, sorry?
Because there's a parameter, so students can make it by their own thoughts, how long is that and how wide is that. So there must be more than one answer for that.
He would propose students a different size but the same area.
Children, when they start working on problems like this, they will start to discover that there is not a one-one relation between area and perimeter. many people think there is a one-one relation. If you know the area, you know the perimeter. If you know the perimeter, you know the area. But there is not. So the next question could be, and that's what you were saying, I need more information, or I need to say something, because I don't know if I make it 20, 5, 5, 5, 5, and then it is not this rectangle, but I should have drawn it as a square, what's also a rectangle, but, or I do it 9, 1, 9, 1. The perimeter is 20 in both cases, but the area is different. So that by itself is already a nice thing for students to think about. But the next question automatically becomes, so what is the largest? Which shape will be the largest? And children work on it and try it, and at one moment they see that the square is the largest. But now we assume that we always have to work with rectangles. But what if we include a six-sided? Or what if we include other figures? What if we include an eight-sided? And so you can look at the six-sided. And if it is regular, then again, the area, but is that area now larger than the square or not? I go for an eight-sided. Hey, what if I do it in 10-sided? What if I do it in... Now, first of all, how do I calculate the area of that six-sided figure? That's already something to think about. But then, the more you get to a circle, the larger it becomes. But every time I'm thinking about what is the area of that one. And so, if I would have to invent, if I would have to try an investigation about area and perimeter of a circle, I would probably go from many-sided figures and trying to get there. It's one of the famous ways to approach the perimeter and the area of a circle by going with things you can calculate. And that would be within reach of the students. I don't know if I would really introduce the formula. I personally don't think that it should be done in primary schools. But then again, there is a difference between what you do in Indonesia in primary schools and what we do. And where the right agenda is, I don't know. I'm not going to say anything about that. There are mathematical approaches of the circle where people, sorry, my drawings will not be too great. Cut up the circle in many smaller parts. And then they lay those parts as a strip. Now, the smaller you make the parts, the closer you get to a rectangle. So, if you do this, you get close to a rectangle, where this is one and half is the other. Half of the perimeter is another. Hey, so I can say something about the relationship between the perimeter and the area. And I get closer to a formula for that. It doesn't give the perfect formula. In a primary school, it might be that I at one moment say, well, we are not going there, but this is how mathematicians calculate it. And I present it as social knowledge. That, out of the blue, would be my take on it. Will it work? I don't know. And we use what we call design research to try that. That means I create a problem, I try it in the class, and I create a problem, I think that that problem will really work, I write down my predictions, I write down what I think will happen in the class. Well, I think that you will say that, and I know you will probably do that, and I know you, I think that you will do that, and that group, I think that they will do that. I have predictions of what will happen, and then I try it. And usually I fail miserably. Something else happened. That means that my problem was not good enough. It doesn't mean my students are stupid, no, it means that I have to change my problem. So either I say, hey, can we do it in your class? Can you try it? And we do it immediately, or I have to wait the whole year. And I try it again. But now I've changed my problem because I know better what might work. And I do it. And so in that cycle, you slowly start to find the best problem to do it. Now, as an individual teacher, that's almost impossible. It costs a lot of time. But that, of course, is why there are researchers at universities. That is why there are people here at Keynote. Yeah. That is why there are groups of teachers working together. And so, if you really say, this fails so miserably in my class, and I don't know how to do it, I would say, create a group of teachers who are teaching the same grade level, work together, create a context, try it in one classroom. It will probably fail. But we learn from our failures. So in the next classroom, we try a better one. And in the next classroom, we try a better one. And in 3 or 4 cycles, we have a problem that really works. And next year, all of you have a problem. Now, of course, you are a different teacher than I am. And you are a different teacher than the two of us. So what works in your classroom might not automatically work in my classroom. So I have to change it to fit my students and my personality. But you told me what worked and why it worked. And I understand why it worked in your classroom. Then I can change it to my classroom. So there is not one solution. There are solutions where we understand why it worked, and then I can use it in my classroom. That means that there is a lot of work for us to do. Hooray, we have things to do. Is that answering the question about the circle?
Dijadikan juring-juring, dipotong-potong, terus nanti lama-lama mendekati jajar genjang nanti mendekati persegi panjang. Kenapa rumusnya bisa jadi PR kuadrat? Karena awalnya adalah tingginya itu kan jari-jari. Nah, yang atasnya itu tuh kan separuh lingkaran kan, separuh keliling lingkaran, jadinya ditemukan luas lingkarannya PR kuadrat. Nah, seperti itu, lebih ke sana. Tapi kalau itu muncul di assessment ASPD bahwa itu soalnya adalah soal prosedural, ya berarti itulah Indonesia yang ditekankan masih menghitung prosedur, ya. Gitu. Mungkin itu, ya. Actually, I have a question from YouTube's viewer. How? Not yet. Okay. Yes. From YouTube, we have questions from Miss Wade. Let me check.
Okay, thank you very much for Miss Fiona Adelia, our YouTube viewer. Martin, I'm Citra from South Kalimantan province. It was very nice to hear your presentation. I have something to ask. How to teach fractions to students in elementary school, especially using multiplication of fractions without going directly with the rules or formula. Okay, that's it.
How many days do I have? Multiplication, you said? Yeah, Pa Wahid, you said multiplication or addition? Multiplication. Okay. This. Or that. We're talking about this. Once again, I think we have to look for models and we have to look for context. So, one of the models that might work is that you have an area that you have to divide. So if we think about 2/3 times 3/5, a model might be that I divide one side in thirds. So 2/3 is that. And I divide the other side in fifths. Five equal parts. I didn't do that. You divide that part in fifths, and now you say, I'm talking about 3/5. So, hey, so I'm talking about 6 out of 15. But the model is not, you don't want to teach by saying, hey kids, here's a model, you do it this way, because that is once again a procedure. So you want a context that would work to invent, to have children invent a model like this. Once they created that model, then it can become, as my colleague Kuno Gravermeyer said, a model to think with. A model that you use when you think about multiplication of fractions. And then in the end, the multiplication of fractions becomes something you do maybe even without a model. So there are steps. You first need a good context. And my colleague, Patty Fosno, and friends designed a context. And so give me a minute. Sorry? No? I don't know what you... want? Oh, no, just give me a second. Oh, it's mean. Let's hope that the video runs, and I hope that when I run the video, people on YouTube can see it. And I hope there is sound.
You know that I live in Brooklyn, and I live near Prospect Park, which is a pretty big park if you live in Brooklyn. And it's great to have a park in your neighborhood, but the problem is that Brooklyn is a really big borough, and there aren't that many little parks. There's not that many places to play basketball, play kickball, or just sit on a bench sometimes in the summer. So the good news is that in 2 neighborhoods in Brooklyn, we're thinking about developing some parks. And one of the neighborhoods is called Carroll Gardens. No? Okay. Carroll Gardens is in Brooklyn, and there's an empty lot in Carroll Gardens, and the lot measures 50 yards by 100 yards. So it looks something like this. So I use graph model, and I'm counting 5 squares to model that this would represent 50 yards. And this dimension of the park, or the lot, represents 100. And it just turns out that 100 yards is about the length between 2 streets. It's about the length of a block. So this is kind of the dimensions of the lot. Here's what they decided in Carroll Gardens. They said of this lot, 3/4 will be devoted to a playground for children. Let's write that. Okay, you can kind of imagine that. And then of the playground, 2/5 of the playground will be covered in blacktop, places where you and I can play basketball and kickball and things like that. I'm going to call that blacktop. That make sense? Well, that's the situation in Carroll Gardens. Now, in another neighborhood in Brooklyn called Flatbush. You heard of Flatbush? Yeah. Okay, me too. The lot is actually the same size. Interestingly enough, it's an empty lot, nothing there at the moment. The lot measures 50 yards by 100 yards. But the discussion in Flatbush is a little different when they think about the playground. They've decided in this neighborhood, in Flatbush, that 2/5 of the lot will devote to a playground. And of the playground, 3/4 of it will be covered in blacktop. So there's a bit of a question in terms of where, which part, if you have more space for blacktop, more space.
I hope the people on YouTube could hear the video. I hope you could hear the video. So, the context of a large area in New York City, it's different than here, and here we need to define a different context. You cannot just use a context that works in one country in another country. You have to find another context. But there, they Kara-im introduced those two. And then she says, 3/4 of the lot will be playgrounds. I could spend the whole morning and we could work on it. That would be very nice. But 3/4, so that is playground. So this is maybe a garden, or water, or something else. But this is the playground. And then 2/5 of the playground, students find that very difficult. 2/5 of 3/4. That is very difficult. But that is what we are talking about. And so some students make all kinds of attempts to understand what 2/5 of 3/4 is. But 2/5, let's see if I can do it now better. Two-fifths is that. And then we have the other one. 2/5 is the playground, and 3/4 of the 2/5. Yeah, mathematically we know it's the same. But the children don't. And so the children have to start to work with what does that really mean? But it has a meaning in the playground. And so the idea of a lot and a playground and a baseball field introduces the idea of this model. So the teacher didn't say you have to make the model. The context suggested to make that model. And now we can compare where am I? Why is that not right? Now I can compare. And students have to find words to compare them. Interestingly, I think that Kara said that this was 50 yards and this was 100 yards. Yard is one of those American measures that doesn't really add up to what we use in meters. But 50 meters by 100 meters. You could calculate every part. And the interesting thing is, when we do this with teachers, I sometimes see the teachers calculate everything. The kids hardly ever use the 50 and the 100. Maybe they find it too difficult, they don't. They start really trying to compare those two. And so they start to talk about 20 smaller units. They start to talk about 6 out of 20. They try to find words to embody what those fractions really mean. There's a context that's meaningful for the children. The children, with some support of the teacher, know how to manipulate in the context. The context suggests a model, and the model allows them to solve the problem. And in doing that, they start to develop an understanding of multiplication of fractions. And that is where the question was. And so we first have to do all this work. This, by the way, starts in kindergarten. Because what we do is that one field is the same as 20 smaller pieces. One piece is 1/20th, is 1, and the whole field is 1, but also 20. We talk about different units. We talk about a distance of 0.5 kilometer is the same as 500 meters. We often talk about different units. But in kindergarten, you already talk about something is 1/10 and it is 10 individual units. So if that idea of reunitizing is not really developed in kindergarten, you get trouble all over the rest of your school. And that is why a lot of things that happen in kindergarten is so extremely important. How can that be 1 and 10 at the same time? I don't know if you ever used in kindergarten those blocks. Where 10 blocks is the same as that length. And when you ask children how many are there, 1, 2, 3, 4, 5, 6. Because there are 6 objects. And to be able to see that this is not one object, yes, it is one object, but it is 10 small blocks, even though I don't see that, is extremely difficult for children. They need time for that. But if this is developed in kindergarten, then it helps here to see the 2 units at the same time. And you have to be able to see the 2 units to be able to understand, yes, that is 1/5, but it is also 5/20, equivalent fractions. And I'm taking 4 out of those 5/20. And another 4. I do it wrong. Excuse me that I used the wrong numbers. So how do I develop an understanding of multiplication of fractions? It's a difficult issue. Find a context that would allow to develop a good model. Now, this context of those 2 plots in New York City is meaningful there. I'm not from Indonesia. I don't know what would be a good context here. But if we want to do it, we have to develop a context that would allow the children to make that drawing. And it needs to be a context meaningful for the children. And now we're back to the design research we talked about earlier. We develop a context, you try it in class. It fails. Terrible for you, but good for us as a group, because we now know more. We have to change this and this in the context. We try it in your class. A little. Children didn't understand it yet, the model was not growing. But we try it in your class. Hey, it goes much better. We try it in your class. Hey, that seems to be a success. We try it in your class. Hey, that's a success. Next year, you try it again, and it works. So, how do we do it? We need cooperation between teachers to develop a great context. Or you just all look at the people at KeyTap and you say, hey, help us. You are the experts. I will do it later. Is that answering the question? The YouTube person cannot say that, but is that answering the question? Okay. I don't know, but before we do that, it's a bit slow. Am I still online? Yes. So just let's listen to the teacher working with one of the students. Just a little bit more looking into a classroom. And if I put the microphone here, you could hear it.
because it's 20%, right? So we should divide the playground into points first, so we can get the playground, and then I think the rest of it would be the blacktop because when you divide it into 8 points, that's the playground, and then the rest of the playground is just going to be blacktop, like you said.
So she divided the playground in 4 parts. But her division is not yet helpful to come to that kind of representation. So there you are as teacher. How can I help her without telling her what to do? Because if I tell her, I make her a calculator. So what can I do? It's always difficult for a teacher. Really doing this kind of work and allowing students to do it, it's a lot of work. I think we just wait a minute. So this girl divided the playground in 4 parts. It's still not impossible. She could say, so I work with those 3. That is 3/4. This one I forget. This one was the garden or the flowers or whatever, I forget. So these 2, I need 2/5. I could divide each block in 5 parts. It's not as neat as that. It is not automatically helping towards the algorithm, but for the moment, it would help her to develop something. So as a teacher, we could start to focus her on those parts. I don't have to say to her, oh, what you did is wrong. Stop. Because what I do then is make sure that she will not enjoy mathematics. If I'm the teacher who always says, oh, that's wrong, you feel so stupid as a child. So I have to find a way to help her continue with what she is doing. So I have to celebrate what she is doing. Oh yes, you have a nice drawing. Yes, I can see the parts and I can see that. And now I have to challenge her to continue. Now, I must say, I don't remember what Kara did, but let's listen into Kara.
Three-fourths of the lot is going to be playground. We agree about that? Yeah. And then in the playground, part of the playground will be devoted to blacktop.
Kara picks up, hey, wait a minute, because that is important. Did you really divide the playground? She didn't. She divided a part of the playground in 4 parts. She didn't divide the whole playground. So, how can I move her from
It's 2/5 of the playground. So that's a little bit different than what you said. You said there'll be another piece that's blacktop. Actually, the blacktop is in the playground. It's a piece of the playground. So that may change how you're thinking. Yeah. Okay, I'll come back and maybe you can get together and think of a way to represent that.
the interpretation of the problem, the interpretation of the situation is the first thing that needs to happen. And when we design it, we might think that all students will do what we have in our mind. And the reality is that many students will interpret it differently. And so we are a little later in the program.
And 2/5 are playground. Did you finish the drawing? No. Oh, no. The 3/4. And then it says the... Let's back up. Did you sheet in 2/5 of their lot? No, because the whole thing would be 2/5. Yeah. But I would do the... I forgot to do the 3/4. I should have done 3/4 first. I wonder if that matters. In this case, you did the 3/4 first, because you were looking for the playground first, and then you kind of covered it in blacktop. You could do the same thing here. You could start with the playground first, and then cover it in blacktop. In this case, this one's a playground. Yeah, exactly. But my question is the playground finished? Does this represent the playground? 2/5 is the playground. Yeah, does this represent 2/5? These two represent these. Let's fill in, no? No, because it's then 3/4 of the blacktop will be this. 3/4 of the blacktop will be this. And then it said 2/5. Okay. So they kind of switch. Hey, wait, by that. Because first this one, the whole thing right here was playground, and then this is the blacktop. But now in this case, the 2/5 is the playground, and now this is the playground. Yeah. Okay, well, I think it might make sense to show the whole playground, and then, like what you did here, cover the playground in the blacktop area. So yeah, we're gonna go like that, and then cover the rest with the black. I'm not sure this represents 2/5 of the lot. The whole thing would represent 2/5. So yeah, so let's think about why are we not calling this 2/5? Because what was the I said earlier about the 2/5 is from the 3/4. Oh yeah, so you would combine this
Who are doing the mathematics? Not the teacher. Of course, the teacher is important. But who are doing the mathematics? The students. So, a lot happened before you get to this point. These children, if you say it impolitely, they talk back to the teacher. I do that because, They defend themselves. The teacher takes them serious. Teacher gives a suggestion at one moment, maybe you can do this. Suggestion is to push them into something that will help them to see more. But the children take responsibility for their work. The children really defend their thinking. The children understand what they have been doing so much that they can talk about it. Now, that will help them to slowly develop that model. You saw one side, 3/4, and here they have the 2/5. But it would be so nice if that was there too, because then you can really compare it. So yes, they kind of are there to build that model for themselves, but they are not there yet. That is where the development starts. That is where understanding of, in this case, multiplication of fractions starts. But I could do the same many other topics. Okay, back to the questions, Barbara. I still have questions here. You go back to YouTube. It doesn't take you serious, guys. Well, the last question is quite simple. Don't. If they don't understand multiplication, you cannot do division. End of story. It's needed to understand it. And it is the story that I told before, where what we did in a school, we slowly want to move from repeated addition to seeing groups, to understanding that multiplication is grouping. You have to understand that you can make groups of groups. You have to understand a lot more. And once you understand that, then division is the same, but now in a subtraction context, in a situation where you constantly want to know how much you still have. The two are related. So in a way, if you don't understand multiplication, start with good context that help you understand multiplication. That is not the same as knowing that 3 times 5 is 15. No, understanding multiplication is really understanding what you do in multiplication. And the repeated addition is one of the things that you can do with multiplication. Some people say multiplication is related to scaling, because repeated addition doesn't allow you to think about 2.5 times 3/4. And so you want a model and an understanding that prepares for this. But the answer is simple, don't. Now the first question was, I tried to understand that question. How do I teach multiplication in primary school, middle school, high school? I don't want to teach multiplication in high school. I want to teach it in primary school. I need to keep students apprised. So I cannot expect that if we did in grade 3 multiplication, that at the end of high school they still know it. If I don't do problems in between, of course they forget. But the big idea about what is multiplication, how does it work, the idea that multiplication has to do with repeated addition, the idea that you have a commutative property, blah, 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 should all be done in primary school. And then I extend those notions. So a lot of what we do in primary school is early algebra. So I extend those notions in algebra. But it is in continuation, it's not the same. So I would not say I do multiplication there. Of course, 3x times y, then I have to find a meaningful context for that. But if your children didn't understand multiplication in primary school, that teacher has a lousy life. More YouTube questions? Can we go back to this group? Guys, you're back in the picture. So, I have some questions here, but I don't know your notes, so I give the notes back, and you can tell me. Oh, the donuts. The question was the donuts. I missed the question. I still don't understand the question. I'm sorry, I'm a bit slow. But what is the difficulty in drawing the donuts? I mean, I start with some box. That's a box, guys. Interestingly, I will come back to that. I will first do the donuts, because then I go to the next context. That was way more difficult. I say to myself, okay, so I need a nice number. And we went for 12. Not too large, not too small. 12 to me is 3 times 4. I know, of course, I don't only know the multiplication facts, but I also know what factors fits in a number. And I know that you know that. If I say 49, you immediately think 7 times 7. Because we were talking about multiplication. If I say 28, I'm not really sure what you think. Do you think 2 times 14? Do you think 4 times 7? If I say 24, it's even more lousy, because there are many products that come to 24. But I know my multiplication facts. So I know that 12 is 3 by 4. So I estimate the middle. I need 2 donuts there. So I go there. And I adjust the size of my donuts a little bit so that they fit. And I'm a lousy drawer. But I want it to make it difficult. This would be too easy to replicate. So to make it more difficult, and if I really want to make it difficult, then indeed I'm going to do, but I didn't do that. I did those holes so that it became extra work. I want the kids to be tired. I want the kids to hate me for that. So that they say, I'm going to do it smarter. But I don't stop, so I'm really and of course, to keep attention and to keep them in the context, because I will constantly talk about donuts. I don't talk about mathematics. I talk about donuts. I don't talk about 12 plus 12. I talk about a box of 12 donuts and a box of 12 donuts. I keep that context there. And of course, while I'm drawing that, I will make remarks about the hole in the donut, and that's the nicest part, and that some shops even sell only the hole, and that kind of things. A lot of extraneous information, but to keep it real. And it gives me time to make that drawing. So, is that answering the question? Is that answering the question?
Ya, Mister. Saya pakai bahasa. Untuk pecahan itu yang biasa jadi masalah di pelajar Indonesia, itu itu adalah penjumlahan dan pengurangan. Nah, bagaimana untuk menyampaikan kepada siswa cara yang lebih mudah? Karena biasanya di permasalahannya adalah bagaimana menyamakan penyebut. Itu yang sulit. Okay, thank you.
Our primary school students have difficulty in addition of fractions and subtraction of fractions. And the basic things that creating the problem is how to make the denominators equals, because it is more procedures in here. So how to cope with that? So addition of fractions, because denominator are not the same. And what we usually do is to make the denominator the same or equal.
I thought you were still talking about the donuts, but you're talking about something else. I park your question for 1 second. I want to talk a little bit more about the donuts. I come back to you. Well, not about the donuts, but I told you 3 problems, day 1, day 2, day 3. On day 3, we used the number 18. And we introduced it as cakes. They were in a small box, like you all know very well, very Indonesian. And we introduced that, and the idea was that those boxes would be packed in a crate. And if you buy 10 crates, the school would get a ball. And so we forced them to think about crates and 10 crates. But I wondered, a drawing of a box with 6 stacks. And so this was the bottom layer. And that was too difficult. So instead of a 3-dimensional, it became a 2-dimensional drawing. And I was kind of surprised, because I thought that kids in grade 3 by now should be able to think about a 3-dimensional drawing and being able to see this as 3 layers being 18. And so there was something about, this of course was 18. You can count them. This is 18, but you cannot count them yet. You have to understand it's 18. And I wanted this because the fact that you could not count them forced you to think about 18, not about counting anymore. It was a constraint in the problem. But in the discussion, we went for that. And so, even in drawings, there is all kinds of choices you have to make. Do I make everything countable? Do I not make everything countable? Do I build in constraints? How do I do that? Is it too difficult for children or not? What do I have to be done before to make that possible? In the Netherlands, in many countries, people work on this kind of, hey, I cannot see all the boxes, how many are there? Okay, I needed to say that. Now you say additional fractions. Okay. I don't want to go there. let me introduce you to Joel. He will do what we call a mini lesson. It's not a context, it is a context in this case, but it is a series of related problems. If you solved one, you might have ideas about the next problem.
Some of you guys know from talking to me about where we live in the city and stuff that I live on the Upper West Side, really close to, had advice for me about how much I should run, how much I should walk, should I do a combination of both. Alex suggested, why? Because I hate that microphone. From talking to me about where we live in the city and stuff that I live on the Upper West Side, really close to Central Park. And recently, I decided I needed to start exercising. So I decided I'd start running in Central Park. That big nice loop. You guys seen the loop in Central Park there? You guys Central Park, right? And when I decided I was going to start running and talking to people, a lot of people had advice for me about how much I should run, how much I should walk, should I do a combination of both. Alex suggested that I start by running for a third of an hour, and then I walk for a fourth of an hour. And I was wondering if you guys could tell me how much time that would be. Dylan.
That's 35 minutes, because 1/3 of a mile, 1/3 of an hour is 20 minutes, and 1/4 of an hour is 15 minutes, and 20 plus 15 is 35.
How many of you guys solved that in similar ways? Anybody think of it a different way?
I kind of did it at like 1 times the denominator, which was 3 for the first one, would give me 60 minutes to an hour.
Okay.
So 20 times 3 gives you 60. So that's how I got 20 minutes, and then 4 times 15 gets you 16 minutes. 60 minutes. That's how I got.
So you thought that 3 times what equals 60? And you thought 4 times what equals 60? And that ended up being, for this one, 20 minutes, and for this one, 15 minutes? And you put them together to get the 35 minutes. Anybody think about it differently? No? What portion of an hour? What part of an hour is that? Lucy, what do you think?
I think that it would be 7/12 of an hour. It can also be 35/60 of an hour, but if you zero it, you reverse it. So, and I thought of it 5-minute chunks, but each 5-minute chunk would be 12.
So if you were looking at a clock, 12 is up here. You were looking at 5-minute chunks like this, and you thought that 5-minute chunk is 1/12 of an hour. So when we're looking at the clock, think of the 6 being here and the 9 being here, and our first fraction was 1/3 of an hour, and you're saying that that was equal to 20 minutes, so that would be right about there from our 12. And then we've got another 1/4 of an hour on top of that, and you said that that's another 15 minutes. There's another 5, 10, another 15 minutes. So that goes all the way over to there, which ends up being our 7/12. Is that what you were thinking? All right. here we had 30 out of 60 minutes. Here we had 40 out of 60 minutes, which altogether gave us 70 out of 60 minutes. Or 1 and 10.
Adding fractions is terrible. So if I can live in the world without fractions, it's much easier. And the idea behind it, you could use a ratio table of a double number line. I want to talk about, in this case, time. So I talk about 1 hour is 60 minutes. All kids know that. He talks about fractions, they answer in minutes. So I put fractions up here, I put time up there. So a whole, 1 hour, is 60 minutes. And so if I want to add a third plus a half, the children live in this world. So the children answer 20 minutes, 30 minutes, 50 minutes. What the children didn't do yet is translated now that world above. But he asked for it, and then they come to, 56 years. Now mathematicians are fools, and they want, well, not the mathematicians per se. It's more, some people in mathematics education think that 56 years is not a serious fraction, you have to say 5/6. But if you know the equivalent fractions, you know that is both the same. 56 years is a good answer. It's equivalent to 5/6, but it is also 56 years. So I would be happy if children say that is 56 years. So instead of that strategy that many of us were taught, you have to find a number that is a multiple of 2 and a multiple of 3, but it has to be smallest. That it has to be the smallest is a procedure nonsense. It's not needed. You can go for a larger number that fits both. And 60 is a nice number for those. This context won't work if you have 1/7 plus 1/11, then I have to find a different context. But that's later in the process. Here we are still introducing the idea of you can live in a world of fractions and you can live in a world without fractions. And at one moment you want the children nicely choose what measure they use in the world without fractions. So if I talk about 3/4 plus 2/5, I have to think about what kind of world would be nice. Well, time would work. 60. But I could also talk about a box with 100 cookies. Or etc., etc. So I want to go for a world without fractions that is meaningful. And I solved that addition problem there. Three quarters, 75. That is something. So I need to know what 3/4 of 100 is. So there are precursors, there are things that I need to know, but that is 75. 2/5 of 100? Oh, that's 40. So I end up 115. That is, the fraction has the name 115 hundredths. And of course, if your teacher really wants you to do, you can now use equivalent fractions to make it smaller. I would be happy if kids said 115 hundredths. The basic philosophy is you don't have to go for the smallest multiple, you go to a handy multiple. And so we start with time, because that is a very meaningful context. You start with a roll of cookies, 50 cookies, or you start with, and you do a number of those additions. You can only do that if the idea of a double number line has been set. If this is a model that is not meaningful for children, you're too early. So before you do this, you have to have that double number line. Well, can I remove it? In that dreadful kilometers to meters, or meters to centimeters, I don't know how you do it, people, all kinds of difficult things with steps of 10 and whatever. I look at kilometers to meters as a double number line. 1 kilometer is 1,000 meters. So I can talk about a third, or about a half. I can also talk about 750 meters, or 1,500 meters. The meters live here, the kilometers live there. It's a context where simple fractions come, where I'm not adding up fractions, but I'm just moving back and forth. And if you really look around, there are many situations where that double number line can become a meaningful situation. The big crates and the small boxes. 1 crate is 18 boxes. 2 crates is, hey, that is also a double number line. So that context that I used earlier, where the children don't use this thinking, in reality, the crate boxes, what we're doing in crate 3 is already a double number line. They don't draw it like that. But it is a double number line. So that ratio thinking is important. And as a teacher, we didn't do that, but as a teacher, and we have a good conversation with children, and we see those repeated additions where they really keep track, I could say, hey, what about writing it down this way? Would that make sense? So, a lot of things, they need to understand the model of double number line, they need to understand how you can go from different units, reunitizing kindergartens, 110 is 10 blocks. We have to do all those things, and then with a good context we can introduce the notion of addition of fractions, where the children do the work and they are thinking and not doing procedures, they are not calculators. And that is what John was doing. Answering your question? Okay. Always happy if people are happy. What do you do with time? It goes so fast. He says I have to stop. It's his fault. Blame him. Thank Thank you, guys. Thank you.
Thank you very much, Martin. We learned a lot from you these sessions, and I hope you can take and bring this back to your schools and share it with teachers, and maybe you might try this kind of thing with your students, whether or not they are thinker or computer. And we learn a lot from you about, kita belajar bahwa di tempat kita di Indonesia kita terlalu buru-buru mengenalkan rumus di awal. Ya, di sana prosesnya panjang supaya mereka paham duluan, tidak terburu-buru untuk menghitung prosedur. Ya, itu yang kita pelajari pada kesempatan pagi ini, numerasi. Dan numerasi tadi banyak kefleksibelan untuk mengoperasikan bilangan. Jadi tidak harus sama persis dengan algoritma yang diberikan biasanya, tapi ada beberapa cara lain yang benar. Dan ada juga model, model dan konteks yang sangat relevan yang bisa diadaptasi. Jadi apa konteks yang ada di New York belum tentu langsung bisa dapat diimplementasikan di Indonesia. Kita harus cari hal-hal yang mirip atau yang serupa gitu. Kalau di sana ada tanah lapang, di sini juga sebenarnya ada kalau tanah lapang ya. Tapi kalau misalkan roti sandwich di sana nggak ada, kita pakai lemper gitu kan. Nah pokoknya harus kita modifikasi, kita sesuaikan ya. Baik, mudah-mudahan bermanfaat. Kami dari panitia maupun dari Ceremonial kita mengucapkan terima kasih sebanyak-banyaknya untuk Bapak Ibu Guru, mudah-mudahan bermanfaat. Satu lagi boleh saya minta request, kertasnya yang untuk mengerjakan Martin boleh ditinggal? Ya, ya, perlu difoto-foto. Ya, baik Bapak Ibu, thank you very much for attending this seminar, and Sikim really appreciate your great participation, and I would like to say thank you for our YouTube viewer. I love you guys there, very interesting questions, and I hope Martin has answered your questions. See you again in another seminar and great agendas from Ceremonial Kitab in Mathematics. Martin, on behalf of the directors, I would like to say thank you. We are looking forward to having you again in the near future. Yes, of course. Yeah, okay. Thank you very much. Give a round of applause again one more time. Thank you. And I'll give this back to the MC.
Okay, thank you very much everyone for attending this seminar. You can take the administrative matters and certificate outside of the room. Thank you.
Very quick. I have